Welcome back, students. We were studying chapter number 15 of subject science, that is some natural phenomena. This is your lecture number 6. This is a summary lecture, so we will summarize the complete chapter in this lecture. Students, you have learnt about floods and drought in the previous classes. Now in this chapter, we will discuss about two other natural phenomena, that is lightning and earthquake. So first of all, we will discuss about the lightning, that what is lightning and how it is observed. You might have seen sparks on an electric pole when wires become loose. And this phenomenon is quite common in rainy season or when wind is blowing and shaking the wires. And you might also have seen sparks when a plug is loose in its socket. Right? So lightning is also an electric spark, but on a huge scale, means on a large scale. So what is lightning? Lightning is an electric spark on a large scale or huge scale. But now the question is, how lightning is observed? This lightning phenomenon is first observed by a scientist whose name is Benjamin Franklin in 1752, and he observed this phenomena by doing an experiment. Okay. He was flying a kite during a thunderstorm and he attached the kite, this is a kite, okay, and he attached the kite to a silk string. This is a silk string and tied an iron key at the other end. And he tied a thin metal wire from the key in this way. This is a thin metal wire which is attached to the key and insert it into a jar. And he also attached a silk ribbon to the key. This is a silk ribbon. Benjamin flew the kite by holding on to the silk ribbon. And after some time, when he brought his fingers near the key, he saw an electric spark between the key and his fingers. This electric spark is lightning. And in this way, Benjamin Franklin observed lightning phenomena by doing this experiment. From lightning phenomenon, a new term is introduced, that is electrical charges. So now we will learn about that what are electrical charges. So students, ancient Greeks discovered a strange property of amber. What is amber? A hard yellowish brown substance which is used in making jewelry or decorative objects. So ancient Greece discovered a strange property of amber. Now what is that property? They found that when amber is rubbed with a cloth, it can attract nearby bits of straw. But now a question arises in our mind that why the amber attract nearby bits of straw? How it's possible? So they made an observation, they come to a conclusion on the basis of their experiments that when two bodies are rubbed against each other, both of them, means both bodies, acquire some charge, and that charge is called as positive charge, whose sign is this plus sign is positive charge, and negative charge, and negative charge is represented by the sign minus. Okay, means when two bodies are rubbed against each other, both bodies acquire some charge, and that charge may be positive charge and may be negative charge, and such bodies are called charged bodies. Okay, means the bodies which are rubbed against each other they become charged. That's why they are called charged bodies. On rubbing each other, some charges accumulate on two bodies. So these bodies are called charged bodies. Okay. So in this way, we have learned that there are two types of charge. First is positive charge and second is negative charge. Okay, positive charge is represented by plus sign and negative charge is represented by the minus sign. So students, now we will try to know the interaction of charges. Means how these two charges interact with each other. It means when positive and positive charge or negative and negative charge come close to each other, then what type of behavior they show, and when positive and negative charge come close to each other, then how they interact. Basically, now we are studying the interaction of charges or interaction between charges, means the interaction between the positive and negative charge. So let us perform an activity to see what happens if two charges come close to each other. Means how the charges interact with each other. So students, our activity number 1 is to know about the interaction between charges. So for doing this activity, take two inflated balloons and hang them in such a way that they do not touch each other as shown in this figure. Now rub both the balloons with a woolen cloth. Okay, rub both the balloons with a woolen cloth and release them. So what do you observe? When you release the balloons, you will observe that some charge is accumulated on the balloons on rubbing with a woolen cloth. Means now your balloons changed into charged balloons. When you rub these balloons with a woolen cloth, some charge is accumulated on both the balloons. Okay, and when you release it for some time, you will observe that the charged balloon, this is a charged balloon and this is a charged balloon, and same kind of charge is accumulated on both the balloons because both the balloons are rubbed with the woolen cloth. That's why same kind of charge is accumulated on the balloon, either the positive charge or the negative charge. So you will observe that a charged balloon repelled the another charged balloon. Okay, this charged balloon repelled the other charged balloon. Like it is shown in this figure, they are repelling each other. Okay, they try to move in different direction, in opposite direction. It means what? One charged balloon repel the other charged balloon. So why it happens? Because of charge. But what kind of charge? Same charge. Same charge is accumulated on both the balloons on rubbing with a woolen cloth. It means what? That the same charges or same charged bodies repel each other. Means our conclusion is like charges or same charges repel each other. Means positive and positive charge and negative charge repel each other. Okay, this is our conclusion, and this is a property of charge that like charges repel each other. Similarly, if we repeat this activity by using two pen refills, means if we are taking two pen refills and we rub the refills with polythene, then again same charge is accumulated on the refill and we will observe that a charged refill repelled another charge refill. Why? Because same kind of charge is accumulated on both the refills by rubbing with a polythene. It means what? Like charges always repel each other. Okay. Now what happens when the charges are not same? When the charges are not of same kind. So to study the behavior of unlike charges, we will perform another activity. Okay. Now this time take a inflated balloon. Okay. And rub this balloon with the woolen cloth and take a refill and rub this refill with polythene. So when you bring the balloon near the refill, you will observe that they attract to each other. But why it happens? Because when you rub the balloon with a woolen cloth, some charge is accumulated on the balloon. Means now the balloon is a charged balloon. And when you rub the refill with a polythene, then some charge is accumulated on the refill also. But now this time the charge accumulated on the refill and the charge accumulated on the balloon are not of same kind. Okay. If positive charge is accumulated on the balloon, it means what? There is a negative charge on the refill. Okay. It means what? They are not of same kind. Charges are not of same kind. And when the charges are not of same kind, it means the charges are not same on the balloon and the refill. And when the charges are not same, means in case of unlike charges, they attract each other. Okay. So we came to a conclusion that unlike charges attract each other. Okay. Unlike charges attract each other. Suppose if a charge is positive and negative charge attract each other, negative and positive charge attract each other. Okay. So how the charges interact with each other? Like charges repel each other. Okay. Like the positive and positive charge repel each other. Negative charge repel each other. Okay. And unlike charges attract each other. Like positive and negative charge. This is a sign of positive charge and this is a sign of negative charge. So positive and negative charge attract each other. Similarly, negative and positive charge attract each other. So these are also called the property of charges, that like charges repel each other and unlike charges attract each other. Okay. Students, we can do many other activities to show that like charges repel each other and unlike charges attract each other. Suppose if we are taking two glass rods and rub them with a piece of silk cloth. Okay. And we are suspending one rod with a silk thread. Now look at this picture. This is a glass rod. This is also a glass rod. Okay. Now we are suspending one rod with a silk thread. This is a silk thread. This is a rod. This is the other glass rod. And we rub the glass rod with a piece of silk cloth. And after rubbing, we are suspending one rod, okay, to a stand. Now, bring the other glass rod near this rod. You will observe that the suspended glass rod moves away from the other glass rod. Okay. I am repeating, you will observe that the suspended glass rod, this is a suspended glass rod, moves away from this glass rod when we bring this glass rod near this rod. Now recall what you have learned about charges, that like charges repel each other and unlike charges attract each other. Now if this rod moves away from the other glass rod, it means what? The glass rod, when rubbed with silk, acquires same type of charge. Okay, when these glass rods rubbed with silk, they acquire same type of charge. That's why they repel each other. Okay. And now remember this point, that the charge acquired by glass rod when it is rubbed with silk is called positive charge. Means when we rub the glass rod with silk cloth, then some positive charge is accumulated on the glass rod, like this. Some positive charge accumulated on the glass rod, and when we bring this glass rod near the suspended glass rod, then this rod moves away from the other glass rod. Okay, so it will show that like charges repel each other. Okay, now consider the other case. Now this time take a glass rod and a ebonite rod and rub this glass rod with silk cloth and suspend it with a silk thread. Okay, and rub this ebonite rod with a piece of fur. And now bring this ebonite rod near the suspended charged glass rod, because this rod is rubbed with a piece of cloth. So now it is a charged glass rod. So bring this charged ebonite rod near the suspended charged glass rod. You will observe that the suspended glass rod gets attracted towards the ebonite rod. Okay, this suspended glass rod gets attracted to the charged ebonite rod. It will attract towards the ebonite rod. And if they are attracting towards each other, then it means the charge accumulated on both the rods are not same. The first thing that we conclude from this activity is that the charge on both the rods are not same. Okay, and secondly, they have opposite and unlike charges as they attract each other. Okay, they have opposite, or we can say they have unlike charges because they are attracting towards each other. And the charge acquired by ebonite rod when it is rubbed with fur is called negative charge. Means when we rub the ebonite rod with fur, then negative charge is accumulated on the ebonite rod. Okay, what type of charge is accumulated on ebonite rod? Negative charge. So, if negative charge is accumulated on this rod, so we can say that positive charge is on the glass rod. Why positive charge? Because glass rod is attracted towards the ebonite rod, and it happens always in case when the charges are not same. So if a negative charge is present on the ebonite rod, then we can say there is a positive charge on the glass rod. Okay, like charges repel each other and unlike charges attract each other. I hope you have understood about the interaction of charge. That is that how can a body be charged? Means how can we charge an uncharged body? Okay, so students, there are three ways to charge an uncharged body. These are by rubbing. Means by rubbing we can charge a uncharged body. Second way is by conduction, and third is by induction. So let us study each way one by one. Our first way is charging by rubbing. So students, our body can be charged easily by rubbing with the other body. Means when two bodies rub against each other, then some charge is accumulated on both of the bodies. For example, when you rub your comb with dry hair 8-10 times, and when you bring it near to the pieces of paper which is on a table, then you will see that the pieces of paper gets attracted to the comb. But why it happens? Why the pieces of paper gets attracted to the comb? Answer is, it happens because the comb gets charged on rubbing with dry hair. It means when the two bodies rubbed with each other, they acquire some charge. Okay, so a body can be charged easily by rubbing with the other body. And one main point is, when the two bodies rubbed with each other, they gain opposite charges. Suppose if there is a positive charge on the comb, then there is a negative charge on the pieces of paper, and we know unlike charges attract each other, that's why these pieces of paper gets attracted to the comb. It means the two bodies rubbed with each other gain opposite charges. Okay. Now this table shows the pair of objects which get charged on rubbing against each other. Okay. In this table we have divided the objects into two classes. First is positive charge and the other is negative charge. Means when you rub the glass rod and silk cloth with each other, then the glass rod gets positive charge and silk cloth gets negative charge. And similarly, when you rub ebonite rod or amber with fur or woolen cloth, then ebonite rod gets negative charge and fur or woolen cloth gets positive charge. Like woolen coat and plastic sheet. When you rub woolen cloth and plastic sheet with each other, then plastic sheet acquire negative charge and woolen coat acquire positive charge, and so on. Okay. Next way is charging by conduction. A body can also be charged by conduction. When a charged object is touched to an uncharged object, the electric charge flows from the charged object to the uncharged object. Suppose when we touch a ebonite rod which is charged to an uncharged object, okay, then the uncharged object also gets some charge. It means what? When a charged object is touched with an uncharged object, then the uncharged object gets some charge, and in this way we can charge an uncharged object also, and by this the object attains the same charge as the charged body. Okay. Suppose if there is negative charge on the ebonite rod, then the other object also gets the negative charge. Okay, that's why we are saying the object attains the same charge as the charged body. And this method of charging a body is called charging by conduction. Okay, this method of charging a body is called charging by conduction. Basically, uncharged body gets charged when it is touched with the charged body. Okay, when the uncharged body is touched with any charged body, then the uncharged body gets some charge. Okay, so this method is charging by conduction. Suppose this is our uncharged metallic sphere whose name is A. This is our uncharged metallic sphere A. And when we touch an ebonite rod with this uncharged metallic sphere, then the metallic sphere also gets some charge. Okay. When we touch an ebonite rod with this sphere, then sphere gets also some charge, and the sphere attains the same charge as the ebonite rod. Our ebonite rod is positively charged, so some charge is also transferred to this metallic sphere. So when we touch an charged ebonite rod with uncharged metallic sphere, then this metallic sphere also gets some charge. So in this way we can charge an uncharged body. This method is called charging by conduction. Our next way is charging by induction. So what is charging by induction? The phenomenon of charging an uncharged conducting body by bringing a charged body near it without making a direct contact between the two bodies is called charging by induction. Okay, now what does it mean? We can also charge an uncharged body only by bringing a charged body near to it, even without any contact between the two bodies. Means, if we bring a charged object near the uncharged object, then the uncharged object also gets some charge. Okay, and the charged body induces an opposite charge on the uncharged body. For example, this is our uncharged metallic sphere A. Okay, this is our uncharged metallic sphere A, and when we bring a charged ebonite rod near to the uncharged metallic sphere, then some opposite charge also accumulate on the metallic sphere. See, this ebonite rod is positively charged. So, when we bring this positively charged ebonite rod near to this metallic sphere, then some negative charge accumulated on the metallic sphere B. Some negative charge appears on the metallic sphere B. Because this is a positive charge and this is negative charge. The charged body induces an opposite charge on the uncharged body. Remember this point. And if we take a negatively charged body, then some positive charge accumulated on the uncharged body. Basically, the charged body induces an opposite charge on the uncharged body. So, an uncharged body can also be charged by induction. This method is called charging by induction. Means charging a body without any actual contact between the two bodies. Okay, this method is called charging by induction. In charging by conduction, the charged and uncharged body touch to each other. Okay, means we need to touch both the bodies. Okay, but in induction method, the charge is induced on the uncharged body even they are not in contact with each other. Okay, this is the difference between the two methods of charging. Now our next topic is transfer of charge. So students, electric charge from a charged object can be transferred to a neutral, means uncharged object. Neutral means uncharged. Okay, through a metal conductor. Means electric charge can be transferred to any other uncharged object with the help of a metal conductor. And you know, we can show transfer of charges from a charged body to an uncharged body by using a gold leaf electroscope. We can also show the transfer of charges by using a gold leaf electroscope. Now, a question arises in our mind that what is gold leaf electroscope? So students, it is an instrument which is used for detecting the presence of electric charge, that whether the charge is present or not, and also used to measure the amount of charge, that how much charge is present. Okay. This is gold leaf electroscope. The essential parts of a gold leaf electroscope are, first is two extremely thin gold foils attached to the lower end of the metal rod are. These are two gold foils. Okay, let's say L and L. L and L are two gold foils which is attached to a metal rod R. This is our metal rod, okay, named as R. This is a metal rod. Which is fitted in a glass jar Z. This is our glass jar. Through an insulating stopper, or we'll say cork, named as F. This is a stopper. Okay. And this is a metal disc. This is a metal disc. Okay. And this is our charged ebonite rod. I am repeating, the essential parts of a gold leaf electroscope are two thin gold foils which is attached to the lower end of a metal rod R. This is complete is a metal rod named as R, which is fitted in a glass jar Z. Okay, and at the top there is a metal disc. Okay, and this is a ebonite rod. This is a charged ebonite rod. Okay, so these are some parts of gold leaf electroscope. So now we will learn that how can we show transfer of charge from a charged body to an uncharged body using a gold leaf electroscope. So for that, first of all, take a charged ebonite rod. Okay, this is positively charged ebonite rod, and now bring this charged ebonite rod near to this metal disc, and now touch ebonite rod with the metal disc. So when you touch the charged ebonite rod with the metal disc, then the metal disc also gets some charge. This method is called charging by induction. As I previously told you that when a charged object is touched with uncharged object, then the uncharged object also gets the same charge. And if there is positive charge on the ebonite rod, then the metal disc will also positively charge. It also gets positively charged. Okay. Now you will observe that the gold foils inside the electroscope diverge, means they move away from each other, and this happens because on touching charged ebonite rod with the metal disc, the charge flows from the load to the gold leaves. Like if there is a positive charge, then the positive charge flows from the metal load to the leaves. And as the gold foils carry the same charge, there is a positive charge, and on the other gold foil there is a positive charge. So as they carry the same charge, so they repel, because we know that like charges repel each other, and because of repelling they diverge. Okay. Therefore, this diverging of gold foil shows that charge can transfer from a object. Like in this, charge is transferred from ebonite rod and then metal rod and to gold foils. So this diverging of gold foils shows that charge can transfer from a charged body to an uncharged body. Okay. And one more point is, remember this, the charge can transfer only with the help of metal conductor. Like here we used a metal disc. Okay. So from this activity, we have proved that a charge can be transferred to a uncharged object through a metal conductor or with the help of a metal conductor. You can take metal disc or you can take any metal like brass, copper, any metal. Okay. So electric charge from a charged object can be transferred to a uncharged object through a metal conductor. Our first topic is story of lightning and thunder. So students, now it's more easier to explain the lightning process because you have already learnt about the charges. Now you are aware that what are charges. So now we will try to know that how lightning occurs. So students, during the development of a thunderstorm, the air current move upwards. Means air move upwards while the water droplets move downwards. Okay. Air moves upward and the water droplets move downwards. And the huge masses of clouds get electrically charged due to friction of clouds with the air. Means clouds get charge. Why? Due to friction of clouds with the air. Because air move upwards and water droplets move downwards. So it creates friction, and due to the friction between the clouds and the air, the clouds gets electrically charged. And then by a process, the positive charge collects near the upper edges of the cloud. Means some positive charge collect near the upper edges of the clouds and the negative charge accumulate near the lower edges. Means positive charge create on upper edges of the cloud and negative charge accumulate near the lower edges. And there is some accumulation of charge near the ground also. Means some positive charge is also accumulated near the ground, as shown in this figure. Okay. What is happening? The positive charges collect near the upper edges of the clouds and negative charges accumulate near the lower edges of the cloud. And some positive charge accumulate near the ground also. And after that, when the magnitude of the accumulated charges becomes very large, the air, which is normally a poor conductor of electricity, is no longer able to resist their flow. It means what? Air allows the flow of charges. When the magnitude of accumulated charges becomes very large, then charge starts flowing in the air. And when the two clouds are brought together by wind, means when they come together by wind, the negative and positive charges met and produce an intense spark in the sky, which is called lightning. It means what? When two clouds are brought together by wind, the charges jump from one cloud to another through the air, and which results an intense spark in the sky, which is called lightning. And this process is called electric discharge. Okay, this process is called electric discharge. Means negative and positive charges met, producing streaks of bright light. We see streaks as lightning, and this process is called an electric discharge. Okay. So I am repeating. First of all, the clouds gets electrically charged due to friction of clouds with air. The positive charge collects near the upper edges of the clouds and negative charge accumulate near the lower edges, and some positive charge also accumulated near the ground. And when the magnitude of these accumulated charges become very large, the air allows the charges to flow. And when two clouds are brought together by wind, as shown in this picture, the negative and positive charges met and produce an intense spark in the sky. Means some spark is produced due to meeting of these charges. Okay, which is called lightning. And this complete process is called electric discharge. Okay. So now a question arises that why a loud sound is produced during lightning? The heat produced during the process of lightning, which heats up the surrounding air, and this air expands suddenly, and due to this sudden expansion of air, it sends a disturbance in the form of vibrations through the air and produced a loud sound, which is called thunder. Okay, this loud sound is called thunder. So this is the reason that we listen loud sound, or loud sound is produced during lightning. Students, it is interesting to know that an electric discharge can also occur between a charged cloud and the earth. When a charged cloud passes over a tall building or tree, then it induces an opposite charge on them and leads to an electrical discharge in the form of lightning strike. This picture shows an electric discharge which occurs between a charged cloud and a tall building. And if the charge build up between the building and the cloud is large, then it leads to an electrical discharge in the form of lightning strike. This is a lightning strike. Okay. These are lightning strike. Okay. These lightning strike can cause to damage to life and property on the earth and also can cause fire. That's why we should not stand under a tree or a tall building during a thunderstorm, because these lightning strike can harm us. It is therefore necessary to take some measures to protect ourselves from these lightning strike. So how can we protect our buildings from the effect of lightning? So it is possible to protect buildings from the effect of lightning by using a device which is called lightning conductors. Okay. Now what are lightning conductors? Lightning conductor is a device which is installed at the highest point on a building to protect the building from the damaging effects of lightning. Okay, it is a safety device which is installed at the highest point on the building. Okay, to protect the building from the damaging effects of lightning. A lightning conductor consists of a metal rod with the spikes at the top and a copper plate attached to the lower end, which is buried into the earth. Now look at this picture. This is a lightning conductor which is installed at the highest point of the building. Okay, and a lightning conductor consists of a metal rod. This is a metal rod with spikes at the top. These two are the spikes. These are spikes at the top. And a copper plate. This is a copper plate which is attached at the lower end, which is buried deep in the earth. Now how it works, how it is useful for us. So whenever a cloud with an electric charge passes over the building, suppose an charged cloud passes over the building, then an equal and opposite charge is built on the pointed end of the lightning conductor. Opposite charge is built. Okay. Opposite charge is built on the pointed end of the lightning conductor, and after that this charge goes to the earth through the metal rod. Okay, there is a metal rod. Okay, and the charge which is on the pointed end of the lightning conductor, this goes into the earth with this metallic rod, and after that the cloud loses all its charge, because all the charge which is in the cloud goes into the earth by this metallic rod. So the cloud loses all its charge, and in this way when lightning strikes the building, it flows to the earth through the metal rod of the conductor and prevents the building from getting damaged. So in this way lightning conductor protect buildings from the effect of lightning. So now I am repeating that how it works. Whenever a cloud with an electric charge passes over the building, then an equal and opposite charge is built on the pointed end of the lightning conductor, and after that this charge goes into the earth through the metal rod, and clouds loses its charge. In this way when lightning strikes the building, it flows to the earth through the metal rod of the conductor and prevents the building from getting damaged. So students, I hope you have understood that what is lightning conductor and how can we protect the buildings from the damaging effects of lightning. So now move to our next topic, that is safety measures. Means what are the safety measures we have to be taken during lightning? So first is, do not stand under a tree during lightning. Why? Because if the tree is hit by lightning, it will also harm you. That's why do not stand under a tree during lightning. Second is, do not remain in an open space. Take shelter inside a building. And you can take shelter in a vehicle also, but all its doors and windows should be closed, because the metallic frames of the vehicles acts as lightning conductors and keep you safe inside it. But do not touch the metal parts of the vehicle, as you may get a shock, because metal is a good conductor. That's why do not touch the metal parts of the vehicle, as you may get a shock. Next point is, do not go on the terrace of any tall building. And you should not even stand under a tall building. Next point is, do not use electrical appliance like TV, computers, etc. Because electrical lines are very good conductors of electricity. That's why do not use electrical appliance. Okay. Next point is, do not take a shower, as water is a good conductor of electricity. Next point is, avoid using landline phones, because lightning can strike telephone cords, metal pipes and electrical wires. That's why it is safer to use mobile phones instead of landline phones. Next point is, do not lie on the ground. Instead of lying on the ground, get down on your feet and then place your hands on your knees with head between the hands. Means in this way. This is called the safe position during lightning. Okay. So do not lie on the ground. Squat low on the ground. Place your hands on your knees with your head between the hands. This is the safe position during lightning. That is earthquake. So what is earthquake and how can we define earthquake? So students, the sudden shaking of the Earth's crust is called an earthquake. Okay, what is earthquake? The sudden shaking of Earth's crust is called an earthquake. It is one of the most deadliest natural phenomena and it causes great danger to life as well as property. Right? And to understand the reason of earthquake, that why the earthquake comes, what is the reason of earthquake, let's first learn about the various layers of earth. Means now we will study about the layers of the earth. This is the structure of earth. So the earth has 3 layers. First is crust, mantle and core. In core Core is divided into two parts, outer core and inner core. This is the structure of Earth. The outermost layer of Earth means this layer. This outermost layer of Earth is called crust, and the layer which lies under the crust means this layer which lies under the crust is called mantle, and the layer which lies below the mantle is called core. This is an outer core and this is an inner core. Okay, so there are three layers of Earth: crust, mantle and core. This outer layer is outer core, okay, and this is an inner core. So first layer is crust. It is the outermost layer of Earth, about 5 to 70 kilometer thick under the land and 6 to 11 kilometer thick at the ocean floor. Means this outermost layer of Earth is called crust. And second is mantle. It lies under the crust. Means this layer, the layer which lies under the crust is called mantle, and it extends up to the depth of 2900 kilometer. It consists of semi-solid rocks and elements like iron, magnesium and calcium are found in this layer. Okay. Our third layer is core. Earth's third layer is core. It lies below the mantle and innermost layer of Earth, and it is divided into two parts. First is outer core and second is inner core. And outer core consists iron and nickel in molten state. Means iron and nickel are found in outer core and it is found in molten state. And inner core is composed mainly of iron. See, this is an outer core, means the layer below the mantle. This is an outer core, and this inner part, inner layer is inner core. Outer core mainly consists iron and nickel, and inner core is mainly composed of iron. Okay, so these are three layers of Earth: crust, mantle and core. So students, now we will try to know that what is the cause of earthquake, that why earthquake comes, what is the main cause. So in ancient times, people did not know about the true cause of earthquakes, but by knowing the layers of Earth, we can explain the main cause of earthquake. So the main cause is movement of the tectonic plates. Now what are tectonic plates? See, the outermost layer of Earth is not in one piece. It is fragmented, and each fragment is called a plate. Okay, the outermost layer of Earth is not in one piece, it is fragmented, and each fragment of the layer of Earth, each fragment of outermost layer of Earth is called a plate, and these plates are called tectonic plates. Okay, so earthquakes are caused by the movement of tectonic plates. The boundaries of the plates are the weak zones where earthquakes are more likely to occur. And these weak zones are known as seismic or fault zones. Okay, these weak zones are known as seismic or fault zones. Means the earth crust is made up of tectonic plates, and when the tectonic plates move, sometimes they collide with each other, and due to collision or due to movement in the tectonic plates, earthquake is formed or earthquake comes. And the boundary of the plates are the weak zones where earthquakes are more likely to occur. And these weak zones are known as seismic or fault zone. Means earthquake occurs at the boundaries of the plates, and these boundaries are the weak zones which are known as seismic or fault zone. It means indirectly we can say the earthquake are more likely to occur in the seismic or fault zones, right? So what is the cause? What is the reason earthquake formed or earthquake comes? Due to the movement in the tectonic plates. Okay, and where it is occurred? At the boundaries of the plates, means at the weak zones, and these weak zones are known as seismic or fault zone. It means we can say that earthquake occur at the seismic or fault zones. Okay, understood? Although we know that what causes an earthquake, but it is not yet possible to predict when and where the next earthquake occur. Okay, we know the reason, we know the cause of an earthquake, but it is not possible to predict that when and where the next earthquake occurs. Okay, and in India, the areas which are most threatened by earthquake are Kashmir, Western and Central Himalayas, Run of Kutch, whole of Northeast Rajasthan. These are some areas which are most threatened by earthquake. And some areas of South India also fall in the danger zone. So we have learned that when two tectonic plates move suddenly towards each other, then earthquake occurs. Okay, now suppose these are two tectonic plates. So when these two tectonic plates move suddenly towards each other, suppose this is moving in this direction, okay, and this tectonic plate moves in opposite direction. So when these two tectonic plates move towards each other, then earthquake occurs. Okay. Now, where it is originate? So the place from where an earthquake originate is called seismic focus. This is a point, okay? This is a point, this is a place from where an earthquake originates, okay? And this place is called seismic focus. And the point which is vertically above the focus. Suppose this is a point, okay, which is vertically above the focus. So the point which is vertically above the focus is called the epicenter. Okay, what is seismic focus? The place from where an earthquake originates, and the point which is vertically above the focus is called the epicenter. And these lines represented the waves which are formed by the earthquakes, or the waves which are forming in the plates, okay, in the tectonic plates, and these waves are called seismic waves. These waves are called seismic waves. Okay, so what is seismic focus? The place where an earthquake originates is called seismic focus. And what is epicenter? The point vertically above the focus is called the epicenter. Okay, all earthquakes are of different magnitudes. So To detect and record the intensity of earthquake, we used an instrument, that is seismograph. Now, what is the function of seismograph? Seismograph is an instrument which detects and records the intensity of waves generated by earthquake. Okay, means by this instrument we can detect and record the intensity of waves. Means basically by this instrument we will try to know that how much intensity of earthquake had come. Okay, so seismograph is an instrument which detects and records the intensity of wave. Now, it is important to note down the magnitude of an earthquake. So, to note down the magnitude of an earthquake, we use a Richter scale. What is Richter scale? The magnitude of an earthquake is measured on the Richter scale. Okay, basically the Richter scale tells us that how much magnitude of an earthquake occurs in a certain region. Okay. The Richter scale has marking from 0 to 9. The intensity of an earthquake on the Richter scale is as follows. If the Richter scale shows 0 to 2 marking, it means the earthquake which comes is unnoticed. Okay. And if it's marking 2 to 4, then the earthquake very mild and it causes no damage. Okay. Means not too harmful for us. And if Richter scale show marking 4 to 6, means earthquake is moderate. Okay. And if Richter scale shows 6 to 8, means destructive earthquake, means it causes damage, it can cause damage. 8 to 9 means very destructive earthquake, means it is too dangerous for us. Means really destructive earthquakes have magnitudes higher than 7. Okay, its magnitude higher than 7 on the Richter scale. And in areas like Kashmir and Bhuj, earthquakes had magnitude greater than 7.5. It means now you can imagine that how much it is dangerous. Okay, and it is also very much harmful, right? So the Richter scale measure the magnitude of an earthquake in this way. See, this picture shows Kashmir earthquake having magnitude greater than 7.5. So now you can imagine that how earthquake is dangerous and how it is harmful for us. So we should take some safety measures to protect from earthquake. But how can we protect ourselves? How can we protect our buildings from the effect of earthquake? So our next topic is protection against earthquake. Means in this topic we will study that how can we protect from the effect of earthquake. How can we protect ourselves from the effect of earthquake? So first is consult qualified architects and structural engineers. It means what? While constructing buildings and houses, architects and civil engineers should keep in mind that how to minimize the effect of earthquake on the structure. Okay, means we should consult qualified architects so that they made our house to keep in mind that how can minimize the effect of earthquake on our houses or on our buildings. Okay, so we should consult qualified architects and structural engineers. Second is in places where earthquake occur, light materials like timber or mud should be used for construction. Why? Because the roofs should be as light as possible. Okay, that's why light materials should be used for construction. Third point, firefighting equipment in the buildings should be kept handy and in working condition. Means that equipment should be in working condition. Okay. Next point is cracks in the walls and ceilings should be repaired. We should repair that cracks on time. Okay. Next point, cupboards, shelves, cabinets, etc. should be fixed firmly on the walls so that they do not fall easily during an earthquake. Okay, because if it falls easily, then it can also harm us. Okay, that's why it should be fixed firmly on the walls. I am repeating, cupboards, shelves, cabinets, etc. should be fixed firmly on the walls so that they do not fall easily. Next point, doors installed in buildings should open outwards. Means doors should open outwards, not inwards, to ensure that they open easily. Okay, so that they can open easily during an earthquake. So doors installed in buildings should open outwards. So by using these practices, we can protect ourselves and our buildings from the effect of an earthquake. Personal safety. It means what should we do if we are inside a building during an earthquake. So in case an earthquake strikes and you are inside a building, follow the steps given below. First is try to leave the building as soon as possible. Second is move to an open area but keep away from electric poles because there is a possibility to fall the poles during earthquake. So that keep away from electric poles, tall trees, signboards, etc. as they could fall on you. Third point, always use stairs to get out of a building instead of using a lift. Okay, always use stairs to get out of a building. Never use a lift. Next point, if you cannot move out of the building, then take shelter under a heavy table and keep your hands over your head. Okay, take shelter under a heavy table and keep your hands over your head. Okay. Fifth point, in case you are in bed, means you are on bed, then place a pillow over your head to protect it. Because in case if something falls on your head, then this pillow protect your head. That's why place a pillow over your head. Okay. Next point, turn off the power supply immediately. Okay. Seventh point, if you are inside a car or bus, stop the vehicle in open area and that area must be away from electric poles, tall trees and buildings. Because during earthquake, the poles, tall trees and buildings could fall on you. Okay, that's why stop vehicle in an area which is away from electric poles, tall trees and building. So these are some steps which protect you from an earthquake. Okay, so follow. Students, your homework is do assignment number 1, which have been uploaded on EdQuark. Solve all the questions which are given in the assignment. So this ends for today's lecture. Thank you.